Today I'm going to discuss about 8:1 mux by using 2:1 mux Verilog code. So, first of all, what is multiplexer? How to design the multiplexer by using Verilog HDL. So, multiplexer is nothing but a data selector. So, if we have multiple inputs, we can process out of multiple inputs, we can process only single input. Depends on the selection. So, here we have two inputs or we have four inputs, we have eight inputs, we have 16 inputs, always the power of two. So whenever we want to be discuss about the multiplexer, so there are the multiple inputs are presenting in this circuit. Out of multiple inputs, you can only select the one input at a time. Depends on our selection inputs. So that's why it is called as data selector. Suppose we have four inputs, something this is called D0, D1, D2, D3. So how many selection lines are required? Here we have required the two selection lines S1 and S0. It is called as 4 into 1 multiplexer. So it has four inputs. So for selecting four inputs, we require two selection lines and it has one output. So the formula is 2 power n is to 1. So 2 power n is the normal inputs, n is nothing but selection inputs, and 1 is nothing but output. So the same way, you can also implementing 2:1 multiplexer like this. It has two inputs, I0 and I1. It has one selection line S, one output Y. So it has the output Y is decided by the selection line. So we have two inputs, but which input is transferred to the Y, that is decided by S only. If S is 0, that means I0 is transferred to the Y. Suppose if S equal to 1 means, so I1 is transferred to the Y. So it's all about depends on the selection. So that multiplexer 2:1 is designed by the Verilog HDL. So here we can start with module, and module name is multiplexer 2:1. It has one output Y and two inputs I0, I1, one selection line. So we can declare all the inputs. Input I0, I1 and input selection line, output Y. So this is the way you can define the port list. So after you define the port list, then you can be decide what is a function. So here, what is a function? So when s equal to 0 means the y is nothing but I0. When s equal to 1 means I1. So here I can use that ternary operator, assign y equal to, whenever s equal to, what is s question marks means? So the first condition is nothing but true condition, which is nothing but 1. When s equal to 1, I1 is transferred to y, s I0 is transferred to y. This is nothing but 2:1 multiplexers. So the same way, here we can design the 8:1 multiplexer. So by using a 2:1 multiplexer depends on the structure. So in the DLD, when you want to implement high level designs by using low level designs, so possible. Here we have 8 inputs, I0, I1, I2, I3, I4, I5, I6, I7. Out of 8 inputs, so at a time only one input is transferred to the output Y or output, depends on the selection. So we have three selection lines are required. So these selection lines are nothing but S0, S1, S2. Why four multiplexers are needed here? You know, right? So if you want to be get the 8, we have only two 2:1 multiplexers. So the first stage we have four 2:1 multiplexer required. So after that, the 4 is divided by the 2, you get two multiplexers are required. Then you get again divide by 2, we get one multiplexer required. This is the why that is the reason. So whenever you want to implement 8:1 multiplexer by using 2:1 multiplexer, so 8:1 is divided by 2:1. Both outputs are same, but input size will be different. So you need to calculate how many multiplexer required for each stage. So I0, I1 connected to the 2:1 multiplexer as I0, I1. Same way, I2, I2, I3 connected to the I0, I1, I4, I5, I6, I7 connected to the I0, I1s. Outputs of the first two multiplexer are connected to the second stage, first multiplexer, and third and fourth multiplexers outputs of stage 1 connected to the stage 2 input 2:1 multiplexers. So this is the connection. So we have total 6 wires are required, W1, W2, W3, W4, and say as well as W5, W6. So these are wires. Wires are used to be connecting purpose. So without except inputs and outputs, which are the signals in the design, we can treat as a wires. So we have total 6 wires are there that we can write the programming module mux 8 is to 1. So it has y I, yes. So I just want to be declared as a vector notation. So we have total 8 inputs. I just follow the vector notation. The maximum size is 7 and the minimum size is uh, 0. Right? So this is nothing but I. The same way, we have three selection lines S0, S1, S2. So that's why S2 down to 0, S. The second is given selection line. We have only single output, it is a scalar. After that, you can declare how many wires are required. We have total 6 wires are required. So in the stage one, on the stage one, we have four multiplexers. So 2:1 multiplexer is duplicate 4 times. So that means 2:1 multiplexer can reuse 4 times. So mux 21, mux 21, mux 21, mux 21. Already we have designed the mux 21. So we can give the specific name to that mux 21. S11, this means stage 1, first 2:1 multiplexer. S12, second multiplexer, third, fourth. So the first multiplexer output is nothing but W1 and inputs are nothing but I0, I1. So in the place of Y, so we can call it as a W1. In the place of I0, I0. The place of I1, I1. The selection line is nothing but S0 because of all the stage 1 selection line is nothing but S0 only. Similar way, I2, I3, S0, second multiplexer. Again, I4, I5. Right? The W3 is nothing but output. Always we can write as the output is W3. Then I4, I5, selection S0. Then W4, I6, I7, S0. The same way you can write. You can extend up to second stage also. Second stage has two multiplexes. It has two inputs, which comes from the previous stage multiplexer outputs. That's why this is the input of 2:1 multiplexer. That's why so output is W5, inputs are W1, W2, selection line is nothing but S1. The second same way, second multiplexer has W6 is nothing but output W6 of the second multiplexer in the stage 2, W3, W4 are the inputs, selection line is nothing but S1. Last multiplexer has we have output, final output is Y or out. So inputs are W5, W6 and selection line is S2. This is the way you can implement 8:1 multiplexer by using 2:1 multiplexers. So in the next video, I will execute the code by using Xilinx Vivado. So please watch my next video also for execution purpose. Thank you.